What would happen if a single image, captured from the islands of Hawaii, revealed something that science cannot explain? Stay until the end, because what you are about to hear will change the way you look at the night sky. This story begins in November of 2025, under one of the darkest and cleanest skies on the planet. It was not a state-of-the-art satellite that captured the anomaly. It was not a multi-million-dollar observatory. It was an amateur astronomer with a telescope that anyone can buy on the internet.
Friends, welcome once again to this space where we explore the mysteries of the cosmos. I am Felipe Suarez, and today I bring you a story that has kept me awake at night. Have you ever felt that the universe is keeping a secret from you? That something up there is waiting for us to discover it? Well, that is exactly what is happening right now with a visitor from another solar system. Are you ready to delve into one of the most fascinating enigmas of our era? Because believe me, this is only the beginning.
The object is called 3I Atlas, and its technical name hides an extraordinary reality. The letter I, written in lowercase, means interstellar. It does not come from our solar system. It comes from another place, from another sun, perhaps from a star that stopped shining billions of years ago. It reached us, traveling through the cosmic void at speeds that defy imagination, and when it finally appeared in our telescopes, it brought with it more questions than answers. The night everything changed was quiet in Honolulu. The air was clean, without the light pollution that ruins observations in big cities. A man, whose name has not reached the mainstream media, pointed his smart telescope toward a specific region of the sky. The equipment he used was a commercial model, the C-Star S50, a device you can acquire for a few $1,000s if you are passionate about watching the stars from your backyard. But that night, that telescope captured something that no instrument had recorded before with such clarity. The image showed the interstellar object 3I Atlas, but not like any comet we have ever seen. What appeared on the screen was a line, a perfect line, thin as the edge of a needle, extending toward the sun. Experts call it an anti-tail. It is a known phenomenon, yes, but it had never been observed with these characteristics before. Normal anti-tails are wide, diffuse, disordered. They are the result of the natural chaos that characterizes comets when they release dust and gases as they approach a star. But this anti-tail was different. It was so straight, so defined, so impossibly perfect, that it seemed drawn with a ruler on the black canvas of space. And here begins the mystery that has the scientific community divided. To understand why this image caused such a stir, we first need to talk about how comet tails work. When a comet approaches the sun, the heat from our star begins to sublimate the ices that make up its nucleus. That process releases gases and dust particles that form what we know as the coma, that bright cloud that envelops the comet. Then, the pressure of solar radiation and solar wind push those materials outward, creating the famous cometary tails. Typical comets develop two distinct tails. The first is the ion tail, composed of electrically charged particles that are dragged directly away from the sun by the solar wind. This tail always points in the opposite direction of the sun, regardless of where the comet is moving. The second is the dust tail, formed by heavier particles that follow a curved trajectory, influenced by both solar gravity and radiation pressure. Now, under very specific geometric conditions, when Earth crosses the orbital plane of the comet, the dust tail can appear to project toward the sun instead of away from it. This is what astronomers call an anti-tail, and it is a legitimate optical illusion, documented and understood for decades. But what the Hawaii telescope captured does not fit any previously observed anti-tail.
This is where I want you to stop for a moment, friends. Can you imagine being in front of your telescope, expecting to see something common, something you already know, and suddenly finding something that should not exist? Have you ever felt that mix of excitement and bewilderment when you discover something that changes everything you thought you knew? Because that is exactly what that amateur astronomer in Hawaii felt, a moment that will go down in history.
The antitails we know have a fundamental characteristic. They are wide and diffuse. This happens because the dust released by comets varies enormously in size, mass, and velocity. There are microscopic grains, medium particles, tiny pebbles, fragments of all imaginable sizes. When we see that material in profile, from the right angle, it appears as a nebulous triangle, like a fan extending toward the interior of the solar system. But the antitail of 3I Atlas showed none of that. Instead of a disordered fan, observers saw a line so thin it seemed traced with a pencil. It was straight, sharp, stable. It did not oscillate. It did not blur at the edges. It did not show the characteristic dispersion of natural cometary dust. The first ones who saw the image thought it must be an error, a digital processing artifact, a sensor failure, an internal reflection of the telescope. But when multiple independent observers reprocessed the original exposures, removed electronic noise, recalculated light dispersion patterns, and compared the results, the conclusion was unanimous. What they were seeing was real. And if it was real, then something very strange was happening with this interstellar visitor. For an antitail to appear as narrow as that of 3I Atlas, the dust particles would have to meet almost impossible conditions. They would have to be almost identical in mass, almost identical in size, almost identical in reflectivity. They would have to have been ejected from the nucleus at practically uniform velocities, and they would have to be perfectly aligned with the geometry connecting the Sun, the comet, and Earth. Nature rarely creates conditions like this. Comets are chaotic objects by definition. Their nuclei are heterogeneous mixtures of ices, rocks, dust, and organic compounds, accumulated over billions of years in the frozen reaches of some planetary system. When they release material, they do so violently and unpredictably. Jets of gas exploding from cracks in the surface, fragments breaking off with no apparent pattern, clouds of particles of all sizes dispersing in all directions. So, why is 3I Atlas different? Why does its antitail seem designed?
Designed, you say? I know that word will have made more than one of you shiver. What if what we are seeing is not the work of cosmic chance? Do you dare to consider that possibility even for a moment? I am not saying we have visitors from other worlds sending us messages, but we also cannot ignore that the data is there before our eyes, defying everything we thought we knew about comets.
The Hawaii image did not only show strange geometry, it revealed a physical paradox that has scientists scratching their heads. Let us look at the problem from the point of view of basic physics. For an antitail to remain so straight and defined, the dust that composes it must be heavy. Heavy particles better resist the pressure of solar radiation. Heavy particles maintain more stable trajectories. Heavy particles remain confined in a narrow sheet, instead of spreading outward, forming the typical fan we see in other comets. So far, everything makes sense. But there is a problem. The antitail of 3I Atlas is extremely bright, and the brightness of cometary dust generally indicates one thing: light and reflective particles, typically composed of ice. Ice is bright because it reflects sunlight with great efficiency, but ice is also light, which means it should be easily pushed by radiation pressure, dispersing in a wide fan instead of staying in a narrow line. On the other hand, heavy particles, like metallic fragments of nickel or iron, or dense rocky grains, are much darker. They absorb light instead of reflecting it. They do not produce the type of brightness we are seeing in the images of 3I Atlas. So, what do we have here? Bright or heavy particles, ice or metal, light or dense material. Conventional physics says it cannot be both things at the same time. However, the Hawaii data suggests exactly that. High reflectivity combined with high mass, intense brightness along with structural stability. This contradiction became the central mystery surrounding 3I Atlas. A comet coming from another stellar system should not produce a tail with these characteristics, unless its composition is radically different from anything we have seen in our own cosmic neighborhood. Scientists began proposing explanations, each more intriguing than the last. The first possibility suggests that 3I Atlas could be a fragment of the core of a differentiated exoplanet. Imagine a rocky world, similar to Earth, that was destroyed by some cosmic cataclysm billions of years ago. When a planet differentiates, its heavier materials sink toward the center, while the lighter ones float toward the surface. If a piece of the metallic core of that world was ejected into interstellar space, it could explain some of the anomalous properties we are observing. The second possibility speaks of a monolithic nucleus with extremely stable rotation. Most comets are irregular bodies that spin chaotically, releasing material in all directions. But if the nucleus of 3I Atlas were a solid and uniform piece, with smooth and controlled rotation, it could produce a much more ordered dust flow than what we see in typical comets. The third possibility is more controversial. Some researchers have suggested, very cautiously, that the dust could be being confined by some type of magnetic field associated with the object. This idea borders on exotic territory, but it is not physically impossible. Certain magnetized materials can maintain ordered structures even in the vacuum of space. None of these explanations has been proven yet, but none has been ruled out either. And it is precisely that uncertainty that has the scientific community on edge.
Let me ask you a direct question, friends. How many times in the history of humanity have we had the opportunity to study an object that comes from another solar system? The answer is very few. Oumuamua was the first we detected just a few years ago. And now we have 3I Atlas. Does it not seem extraordinary to you that both interstellar visitors have turned out to be so strange? What is the universe telling us?
There is something more that makes this observation particularly unsettling, and it has to do with the stability of the phenomenon. When astronomers observed the anti-tail of 3I Atlas over multiple consecutive nights, they expected to see changes. Comets are dynamic objects. Their tails pulse, twist, fragment. The solar wind is variable, and the outgassing of the nucleus changes constantly as different regions of the surface become exposed to the sun's heat. But the anti-tail of 3I Atlas remained stable. Its brightness did not oscillate significantly. Its direction did not change. Its geometry did not deform. Night after night, the same perfect line appeared in the images, as if someone had drawn a line in the sky and forgotten to erase it. This stability is, in itself, an anomaly. Small comets normally spin chaotically. Their outgassing is violent and random. Their tails flicker and change shape with each rotation of the nucleus. But 3I Atlas seems organized. It seems controlled, as if something were keeping that structure in place. The question that naturally arises is, what could cause such stability? One possibility is that the object's nucleus is composed primarily of dense metal with a very high angular momentum. Such an object would spin smoothly and predictably without the chaotic oscillations that characterize more irregular bodies. Another possibility involves a uniform crust of volatile materials, distributed so homogeneously that sublimation occurs in a balanced manner across the entire surface, without creating the asymmetric jets that make other comets wobble. A third possibility, more speculative, suggests some type of magnetic confinement of electrically charged dust. Dust particles in space can acquire electric charge through interaction with the solar wind, and a sufficiently strong magnetic field could keep them organized in precise geometric structures. Each of these explanations implies a radically different origin story for 3I Atlas, but all point to the same conclusion. This object is different from anything we have seen before. And here we come to a statistical fact that few are openly discussing.
Do you know what I find fascinating about all this? That we are talking about probabilities. Science works with numbers, with statistics, with calculations that tell us how likely something is to occur, And when we put together all the anomalies of 3I Atlas, the numbers start to get very, very interesting. Do you want to know what those probabilities are? Because I assure you they will surprise you.
Let us consider for a moment all the unusual characteristics that 3I Atlas exhibits simultaneously. It has an ultra-thin anti-tail, something that has never been observed with this precision before. It shows extreme rotational stability, without the chaotic oscillations typical of small comets. It presents high reflectivity, combined with what appears to be high mass, an apparent physical contradiction. Spectral emissions have been detected that suggest the presence of unusual metals in its composition. And perhaps most intriguing of all, non-gravitational acceleration has been observed, a change in its trajectory that cannot be explained solely by the Sun's gravity. If we calculate the compound probabilities of all these characteristics occurring together naturally in a single object, we arrive at extraordinarily small numbers. We are talking about probabilities in the range of 1 in several billion. Now, it is important to be clear here. This does not prove that 3I Atlas is artificial. It does not prove that it has an intelligent origin. It proves absolutely nothing in that sense. What it does prove is extreme rarity, and extreme rarity, in science, always demands extraordinary investigation. When something deviates so dramatically from what is expected, we cannot simply shrug our shoulders and move on. We have the scientific obligation to examine the phenomenon with all the tools at our disposal, to consider all possible hypotheses, to follow the data wherever it leads us. And that is exactly what a segment of the astronomical community is doing, although not without controversy. The response to the Hawaii discovery divided scientists into two clearly differentiated camps. On one hand is what we could call the conventional explanation. Most astronomers argue that what we are seeing is a natural effect, although certainly extreme. According to this view, the dust of 3I Atlas is heavy and uniform due to the particularities of its interstellar origin. Earth is seeing the dust sheet exactly in profile, creating the illusion of a perfect line. As our planet exits the orbital plane of the comet, the anti-tail will disappear or change shape, confirming that it was a geometric effect. This interpretation fits well with Occam's razor, the scientific principle that indicates we should prefer the simplest explanations when we have multiple options. According to this view, 3I Atlas is simply a fragment of a metal-rich planetary core ejected from another stellar system eons ago. Nothing more, nothing less. But there is another camp, smaller but equally vocal, that is not satisfied with that explanation.
This is where the story gets really interesting, friends, because not all scientists agree. And when the brightest minds on the planet start debating about something that is crossing our sky at this very moment, we should all pay attention. Do you not think so? Which theory seems more convincing to you so far? I would love to know what you are thinking.
The group of researchers questioning the conventional explanation includes respected names in the astronomical community. They point out several issues that, according to them, have not been adequately explained. First, they argue that natural dust clouds are never as uniform as what we are seeing. The physics of cometary sublimation inevitably produces a heterogeneous mixture of particles. Even if the nucleus were perfectly homogeneous, the material release process would introduce random variations. Second, the anti-tail remains stable for longer than models predict. The geometric conditions for seeing such a narrow anti-tail are very specific, and Earth should have exited that observation window faster than what occurred. Third, the geometry is too precise to be the result of random outgassing. The gas jets that drive dust release in typical comets create complex and variable patterns, not perfect lines. Fourth, and perhaps most significant, non-gravitational acceleration has been detected in the trajectory of 3I Atlas. The object is changing speed in a way that solar gravity cannot explain. This same characteristic was observed in Oumuamua, the first confirmed interstellar object, and remains an unsolved mystery. And fifth, no visible jet has been identified that could explain that acceleration. In normal comets, non-gravitational acceleration is caused by the rocket effect of gas jets. But in 3I Atlas, those jets do not appear in the images. It is important to emphasize that these researchers are not claiming the object is artificial. They are not shouting that there are extraterrestrials in our solar system. Their argument is more subtle and, in a sense, deeper. They are saying that something is happening here that our current models cannot satisfactorily explain. They are asking that we not force the data to fit preconceived theories just because that is more comfortable for us. Physicist Avi Loeb, director of the Galileo project at Harvard University, has publicly commented on 3I Atlas. Loeb is known for his willingness to consider unconventional hypotheses, and he was one of the first established scientists to suggest that Oumuamua might have an artificial origin. About 3I Atlas, Loeb has noted that the monolithic nature of the anti-tail defies conventional explanations of cometary behavior. He is not claiming that the object is an extraterrestrial spacecraft or a probe from another world. What he is saying is that the anomalies are significant enough to justify extraordinary investigation. This position has earned him both admirers and critics. Some see him as a brave scientist willing to follow the data wherever it leads. Others accuse him of sensationalism and of damaging the credibility of serious astronomy. The debate continues.
And what about the official space agencies? What are NASA and the European Space Agency saying about all this? Because, and this seems very curious to me, the silence from some institutions has been almost as notable as the discovery itself. Why might that be? Are they waiting for more data before speaking, or is there something more behind that caution?
The European Space Agency has maintained an officially conservative position regarding 3I Atlas. They have classified the object as an interstellar comet with unusual but natural properties. However, in their communications, they also openly acknowledge that the structure of its anti-tail requires additional modeling to be fully understood. Dr. Michael Kuppers, project scientist for the European Space Agency's Comet Interceptor mission, has offered a moderate perspective. In recent interviews, he has explained that narrow anti-tails, although certainly rare, have been observed in some comets of our own solar system under specific geometric conditions. According to his analysis, the key is in the viewing angle. If we are seeing the dust sheet exactly in profile, it will appear as a thin line regardless of the actual composition of the material. This explanation has scientific merit. Observation geometry can create surprising visual effects that do not necessarily reflect the actual structure of the object. It is like looking at a vinyl record exactly edge on. It looks like a line, even though we know it has depth. However, other astronomers point out that this geometric explanation by itself does not resolve all the anomalies. It does not explain why the particles seem to be so uniform in size and mass. It does not explain the prolonged stability of the structure. It does not explain the combination of high reflectivity and high mass, and it does not explain the non-gravitational acceleration. NASA, curiously, has remained in relative silence about this specific discovery. No detailed public analysis has been issued about the Hawaii image. There have been no official statements about the implications of the ultra-thin anti-tail. The only declarations have been general, confirming that the object is being monitored along with other celestial bodies of interest. This silence, whether intentional or simply a result of the normal rhythms of scientific bureaucracy, has fueled speculation in online amateur astronomer communities. Some interpret the lack of comments as a sign that something extraordinary is happening, and authorities do not know how to handle it. Others, more skeptical, argue that there is simply nothing particularly notable to report beyond what we already know. The truth is probably somewhere in between. Space agencies are large and complex institutions with established protocols for public communication. They do not usually comment on phenomena until they have conclusive data and peer-reviewed analyses. The fact that they have not issued dramatic statements does not necessarily mean they are hiding something, but it also does not mean there is nothing to investigate. Meanwhile, telescopes around the world continue pointing toward 3I Atlas, collecting data that will be analyzed for months and years to come.
I want you to think about something for a moment, friends. We are talking about an object that comes from another solar system, a piece of rock or ice or metal or who knows what, that formed around another star, perhaps billions of years ago. Can you imagine the journey it has made to get here? The distances it has traveled in the absolute darkness of interstellar space? It is hard not to feel small before something like this, is it not?
There is an aspect of this story that transcends the technical debates about anti-tails and chemical composition. It has to do with what it means for us, as a species, to receive visitors from other stellar systems. For most of human history, comets were seen as omens, signs from the gods, messengers of disaster, auguries of change. The appearance of a bright comet in the sky could provoke wars, overthrow kings, inspire prophecies of the end of the world. The ancients had no way of knowing what those luminous objects that suddenly appeared and then vanished really were. They could only interpret what they saw through the lens of their beliefs and fears. Then came the scientific era, and comets became something different. They stopped being divine messages to become objects of study, celestial bodies that taught us about the composition of the solar system, about the origins of the planets, about the chemistry of the early universe. Space missions visited comets, took samples from their tails, analyzed their nuclei. Mystery gave way to knowledge, or so we thought. And now, with objects like Oumuamua and 3I Atlas, we enter a new era, an era in which comets can be time capsules from other worlds, fragments of cosmic stories we will never know directly, pieces of planets that exploded eons ago in stellar systems that no longer exist, messengers not from gods, but from distant stars, bringing information about places we can never visit. Every time one of these interstellar objects crosses our solar system, it brings with it a gift, the opportunity to study material that formed under conditions completely different from those of our cosmic neighborhood. It is like receiving a letter from an unknown sender, written in a language we are just beginning to decipher. And 3I Atlas, with all its anomalies and mysteries, is perhaps the most intriguing letter we have received so far. The question that many are asking, although few dare to voice out loud, is whether some of these visitors might carry signatures of processes we do not fully understand. Not necessarily artificial, but different. Products of physics or chemistry that do not exist in our solar system. Results of conditions we have never directly observed.
And here I want to be very clear with you because I know some of you will be thinking exactly what I thought when I first heard this story. Are we talking about something built by another civilization? Is that what the data suggests? The honest answer is we do not know. And that uncertainty, that openness to the unknown, is precisely what makes this so exciting.
It is important to maintain perspective as we navigate these unknown waters. The vast majority of scientists studying 3I Atlas believe that we will eventually find a natural explanation for all its anomalies. That is what has historically happened with most astronomical phenomena that initially seemed inexplicable. Science advances slowly, methodically, building understanding piece by piece. Perhaps 3I Atlas is the core of a destroyed planet, ejected from its system billions of years ago. Perhaps it comes from a chemical environment so different from ours that its properties seem strange to us, simply because we have no frame of reference. Perhaps the models we use to understand comets were developed exclusively with objects from our solar system and need to be expanded to accommodate visitors from other places. All of these are reasonable and scientifically valid possibilities. But it is also true that science progresses not only when we confirm what we expect, but when we find something that does not fit. Anomalies are the engine of discovery. They are the cracks in our knowledge through which the light of new truths filters. And 3. Atlas presents enough anomalies to justify paying attention. The Hawaii image, captured by an amateur astronomer with a commercial telescope, represents an extraordinary moment in the history of human discovery. It is a reminder that science is not the monopoly of large institutions, that anyone with passion, dedication, and the right tools can contribute to the advancement of knowledge, that the mysteries of the cosmos are out there, waiting for whoever has the patience to seek them. The coming weeks will be crucial. As Earth moves in its orbit and changes its relative position to 3I Atlas, astronomers expect to see changes in the anti-tail. If geometry is solely responsible for its current appearance, it should widen and blur as we exit the orbital plane of the comet. If it remains narrow and defined beyond what models predict, questions will multiply. Telescopes around the world are monitoring the object continuously. Spectrometers analyze the light it reflects, searching for chemical signatures of specific elements. Radars attempt to determine its size and shape with greater precision. Each piece of data collected is another piece of the puzzle.
Do you know what impresses me most about all this? That it is happening now. We are not talking about something that happened decades or centuries ago. 3I Atlas is crossing our sky at this very moment. While you listen to this, there are telescopes pointing at it, scientists analyzing data, researchers debating theories. It is live history, friends, and we are all witnesses.
The date of December 19th, 2025, has been marked on the calendars of many observatories around the world. It is expected that by then, observation conditions will have changed enough to provide crucial information about the true nature of the anti-tail. If it turns out to be a geometric illusion, as the conventional interpretation holds, we will have an interesting story about an interstellar comet with unusual but natural properties. We will learn something new about the diversity of objects that populate our galaxy, and we will move on. If it turns out to be something more, something that our current models cannot satisfactorily explain, then we will be facing a discovery of historical proportions. Not necessarily evidence of intelligent extraterrestrial life, but perhaps evidence of unknown physical or chemical processes, of radically different stellar environments, of phenomena we have never had the opportunity to study before. Whatever the result, one thing is certain. We are witnessing one of the most important observational events of this decade, an event that will be studied, debated, and reanalyzed for years to come. An event that reminds us that the universe is not obligated to follow our rules or fit into our expectations. We are the ones who must learn to follow its clues. And as we watch this visitor from another world traverse our solar system, carrying chemical secrets from a place we will never see, we are forced to confront a truth that is simultaneously humbling and beautiful. We are small, we are curious, and we are only beginning to understand. The days ahead will bring more observations, more spectra, more data. They will bring debates among scientists, articles in specialized journals, analyses and counter-analyses. They will bring certainties and new questions. They will bring confirmations and surprises. And perhaps, just perhaps, they will bring the recognition that what we considered impossible is, in fact, happening before our eyes.
We have reached the end of this journey, friends, but the story of 3I Atlas is only beginning. I want to thank you for accompanying me this far, for paying attention, for keeping an open mind. I have a question for you before I say goodbye. Have you ever looked at the night sky and felt that there is something up there waiting for you? That the universe has messages for those willing to listen? I would love to know what you feel when you look at the stars.
The amateur astronomer who captured the image from Honolulu probably did not imagine that his nighttime observation would unleash such a scientific storm. He probably just wanted to spend a quiet night looking at the cosmos, like so many other nights before. But the universe had other plans. That is the beauty of space exploration. You never know when the next discovery will come, or where it will come from. It can come from a multi-million-dollar orbital telescope, or from an amateur in their backyard. It can come from decades of planned research, or from a casual observation on a clear night. The only thing required is to be looking, to be attentive, to be willing to see what is really there instead of what we expect to be there. 3i Atlas is teaching us that lesson in the most dramatic way possible. It arrived in our solar system without invitation, bringing with it properties that defy our understanding. It did not ask permission to be different. It did not adjust to our models for convenience. It simply is what it is, and it is up to us to decipher what that means. In a sense, that is the fundamental challenge of all science. Not to impose our ideas on reality, but to let reality reveal its secrets at its own pace, on its own terms. The cosmos does not owe us easy explanations. It is not designed to satisfy our curiosity conveniently. Sometimes it keeps its mysteries for millennia. Sometimes it reveals them all at once, in a single image captured by a commercial telescope in the islands of Hawaii. What we do with that revelation is up to us. We can ignore it. We can force it to fit what we already believe. Or we can take it for what it is, an invitation to expand our understanding, to question our certainties, to marvel at the infinite complexity of the universe we inhabit. 3i Atlas will continue its journey. It will pass near the sun, move away from our system, eventually disappear into the darkness of interstellar space from which it came. And we will remain here, with the data we could collect, with the questions we could not answer, with the memory of something extraordinary that crossed our sky for a brief cosmic instant. But perhaps that is enough. Perhaps the question is more valuable than the answer. Perhaps the mystery is, in itself, the gift. Because in the end, it is not just about knowing what 3i Atlas is. It is about remembering that out there are infinite things we do not know, infinite secrets waiting to be discovered, infinite wonders that surpass our boldest imagination. And that, friends, is perhaps the greatest gift an interstellar visitor can bring us. Not certainties, but wonder. Not answers, but humility before the unknown. Keep your eyes on the sky. Keep your mind open to anomalies, and have the courage to question when the universe shows you something that should not exist. Because sometimes the impossible exists.
This has been all for today. If this story made you feel something, if it reminded you of a moment in your life when you looked at the sky and wondered what lies beyond, I would love for you to share it in the comments. What part of this story resonated most with you? Was there something that made you think about your own experience? If you want to continue exploring these mysteries of the cosmos together, I invite you to subscribe to the channel. There will always be a space here for those who look at the stars with curiosity and respect. See you soon, friends, and remember, the universe always has something new to tell us.
And so, while 3i Atlas continues its silent journey through our solar system, we remain here, looking upward, wondering, dreaming. Perhaps someday we will have all the answers. Or perhaps, as has happened so many times before, each answer will bring with it 10 new questions. But that is fine. That is precisely what makes it worth continuing to search. The night sky has not changed much since our most remote ancestors first looked up and wondered what those twinkling lights were. The stars are still there. The planets still follow their orbits. Comets still appear and disappear according to rhythms we are only beginning to understand. What has changed is us, our ability to see farther, to understand deeper, to ask more precise questions. And with each new tool we develop, with each new telescope we point at the sky, the universe reveals a little more of itself. 3i Atlas is just the most recent of those cosmic gifts, a messenger from another sun, a fragment of another world, an anomaly that forces us to rethink what we thought we knew. And while the scientific community debates, while data accumulates, while theories are proposed and discarded, one truth remains constant. The universe is bigger, stranger, and more wonderful than we could ever imagine. And we, small inhabitants of a small planet orbiting an ordinary star in the suburbs of a galaxy among billions, have the extraordinary privilege of witnessing its magnificence. That in itself is a miracle that no anomaly can eclipse.